Sleep is much more than just rest. It is a vital, active process that plays a crucial role in our overall health and well-being. It is an active process crucial for our physical and mental well-being. When we sleep, our bodies repair themselves and our minds process the events of the day. One of the most remarkable benefits of sleep is its profound impact on memory. Our brains are incredibly busy during sleep, organizing and storing the information we've gathered. During sleep, our brains work tirelessly to consolidate memories, transferring them from short-term storage to long-term retention. This process is essential for learning and retaining new information. Without sufficient sleep, our memories become vulnerable to fading and loss. We may find it difficult to concentrate, make decisions, or recall important information. This is why pulling all-nighters or consistently skimping on sleep can be detrimental to learning and academic performance. Lack of sleep impairs our cognitive functions and hinders our ability to absorb new material. Sleep acts as a powerful tool for memory consolidation. It allows our brains to sort through the day's experiences and solidify the knowledge we've gained. When we prioritize sleep, we are essentially giving our brains the opportunity to strengthen and solidify the information we have acquired throughout the day. This leads to better recall and understanding. By understanding the intricate relationship between sleep and memory, we can unlock our cognitive potential and enhance our ability to learn, retain, and recall information effectively. Prioritizing sleep is not just about rest, it's about empowering our minds to perform at their best. Our brains are constantly bombarded with sensory information. This information is initially stored in short-term memory, a temporary holding area with limited capacity. During sleep, the brain works to transfer these fragile memories to long-term storage. This process involves a complex interplay of brain regions and neurochemicals. One crucial player in this process is the hippocampus, a seahorse-shaped structure deep within the brain. The hippocampus acts as a memory hub, receiving information from various sensory areas and binding them together. As we sleep, the hippocampus replays these memories, strengthening the connections between neurons and solidifying the memory trace. This process of strengthening connections is known as synaptic plasticity, and it is essential for long-term memory formation. Sleep is not a uniform state. It cycles through different stages, each characterized by distinct brainwave patterns and physiological changes. These stages are essential for various bodily and cognitive functions, including the vital process of memory consolidation. These stages play unique roles in memory consolidation, ensuring that our experiences and learned information are effectively stored and recalled when needed. Non-rapid eye movement, NRM sleep, particularly slow-wave sleep, SWS, is crucial for consolidating declarative memories, such as facts, events, and concepts. This stage of sleep is marked by slow brain waves and is often referred to as deep sleep. During SWS, the brain reactivates memories, transferring them from the hippocampus to the neocortex, the brain's outer layer responsible for higher-level cognitive functions. This transfer is crucial for the stabilization and long-term storage of these memories. Rapid eye movement REM sleep, characterized by vivid dreams and increased brain activity, is thought to be involved in consolidating procedural memories such as motor skills and habits. This stage is marked by rapid movements of the eyes and a high level of brain activity similar to wakefulness. REM sleep also contributes to emotional memory processing, strengthening memories associated with strong emotions. This helps in managing and regulating our emotional responses and experiences. The intricate dance between REM and REM sleep throughout the night ensures that different types of memories are effectively consolidated and integrated into our long-term memory stores. This dynamic interplay is essential for maintaining cognitive health and overall well-being. Have you ever noticed how quickly new information can slip your mind? This phenomenon is known as the forgetting curve. Research shows that we tend to forget a significant portion of new information within a short period if we don't actively try to retain it. Sleep plays a crucial role in combating the forgetting curve. By consolidating memories, sleep helps to prevent or slow down the rate of forgetting. When we get enough sleep, our brains have the opportunity to strengthen and stabilize memories, making them more resistant to decay. Furthermore, sleep helps to reduce interference from new information. As we encounter new experiences, our brains need to integrate them with existing knowledge. Sleep provides a period of consolidation, allowing the brain to process and organize memories without the distraction of incoming stimuli. The hippocampus, the brain's memory weaver. Nestled deep within the temporal lobe, the hippocampus is a small but mighty structure that plays a pivotal role in memory. This seahorse-shaped region acts as a memory encoder, receiving information from various sensory areas and binding them together to form new memories. The hippocampus is particularly important for declarative memory, which encompasses our conscious recollection of facts, events, and experiences. It's also involved in spatial memory, helping us navigate our surroundings and remember locations. Damage to the hippocampus can have profound effects on memory. Individuals with hippocampal lesions often experience anterograde amnesia, a condition characterized by the inability to form new memories. They may be able to recall past events, but struggle to remember new information or experiences. Patient HM, a case for the hippocampus. The critical role of the hippocampus in memory was famously illustrated by the case of patient HM, one of the most studied cases in neuroscience history. HM underwent surgery to treat severe epilepsy, which involved removing portions of his medial temporal lobes, including the hippocampus. Following the surgery, HM experienced profound anterograde amnesia. While he could recall memories from before the surgery, he was unable to form new declarative memories. HM could learn new motor skills, but had no conscious recollection of the learning process. HM's case provided groundbreaking insights into the role of the hippocampus in memory consolidation. It demonstrated that the hippocampus is essential for transferring memories from short-term to long-term storage, particularly for declarative memories. The emotional imprint on memory. Emotions play a powerful role in shaping our memories. Experiences that evoke strong emotions, whether positive or negative, tend to be more vividly remembered than mundane events. This is because emotions trigger the release of hormones, such as adrenaline and cortisol, which enhance memory consolidation. The amygdala, an almond-shaped structure located near the hippocampus, plays a crucial role in emotional memory. The amygdala attaches emotional significance to experiences, influencing which memories are prioritized for long-term storage. During sleep, the interplay between the hippocampus and the amygdala strengthens the consolidation of emotional memories. This is why we often wake up feeling more emotional about events that happened the day before, as our brains have had the opportunity to process and consolidate the emotional aspects of those memories. Sleep for Success practical tips for memory enhancement. Given the profound impact of sleep on memory, prioritizing sleep is essential for optimal cognitive function. Quality sleep helps consolidate memories, making it easier to recall information when needed. Here are some practical tips to enhance your memory through sleep. Establish a regular sleep schedule. Go to bed and wake up around the same time each day, even on weekends, to regulate your body's natural sleep-wake cycle. Consistency is key to training your body to know when it's time to sleep and wake up. Create a relaxing bedtime routine. Wind down an hour or two before bed by engaging in calming activities, such as taking a warm bath, reading a book, or listening to soothing music. This helps signal to your body that it's time to relax and prepare for sleep. Optimize your sleep environment. Make sure your bedroom is cool, dark, and quiet. A comfortable sleep environment can significantly improve the quality of your sleep. Use blackout curtains to minimize light exposure and earplugs to block out noise. These small adjustments can make a big difference in how well you sleep. Avoid caffeine and alcohol before bed. These substances can interfere with sleep quality and disrupt memory consolidation. Get regular exercise. Physical activity can improve sleep quality, but avoid exercising too close to bedtime. Take naps strategically. Short naps can boost alertness and cognitive function, but long or late afternoon naps can interfere with nighttime sleep. Aim for naps that are 20-30 minutes long to avoid grogginess and ensure they don't disrupt your regular sleep schedule. Conclusion. Unlocking your memory's potential through sleep. Sleep is an indispensable pillar of memory consolidation. During sleep, our brains work tirelessly to transfer memories from short-term to long-term storage, strengthening connections between neurons and solidifying the memory trace. By understanding the intricate relationship between sleep and memory, we can unlock our cognitive potential and enhance our ability to learn, retain, and recall information effectively. Prioritizing sleep is not a luxury, it is an investment in our cognitive health and well-being. Don't forget to subscribe for more interesting facts and tips on enhancing your cognitive abilities.